So let's discuss some questions on today's contest, which was Codeforces round 957 div 3. So let's go on from first problem to the seventh problem, like which was at least the problems which I solved. We'll go for the first four problems very fastly because many people already solved it. Last couple of problems we'll discuss in depth. Okay. So the first problem says chemist has written three integers a, b, c in order to remember that he has to give at least a into b into c bananas. So what this guy can do, he can at most five times he can like increment any one of these numbers at most five times, and after that you have to print the maximum possible product. Okay, so one thing which is very common and always remember that, so if you want to maximize the product, always increase the smaller value. I don't want to go in depth of this statement. You can take a couple of examples and find it out for yourself. But whenever you want to maximize the product, you should always increase the smaller value. So basically, you put this in an array, sort it, increment the smaller value once, again sort it, increment the smaller value once, again sort it, increment the smaller value once. Do it five times and then take the product. You will get your answer. Okay. So while 5 minus minus sort increment a of 0, that's it. So you have three input, so this is enough, and then just print a of 0 into a of 1 into a of 2. That's it. This problem will be solved. Problem number 2. Okay, so what does this problem say? Let's move on to second problem page. Okay, this problem was also very easy. I don't want to go on reading the problem. I hope you have read the problem already. I'll just explain the problem in short. So what you're given an array. So you're given some elements. What you can do, what you want is to convert all the elements in a single element, and the operations which are allowed are, if the number is not equal to 1, you can divide it in this form. So if the number is 5, you can divide it in 1 comma 4. If the number is 11, you can divide it in 1 comma 10. And if there exists, this is type 1 operation, and if there exist two numbers, one of which is 1, other is non 1, some let's say a, then you can convert these numbers to a plus 1. So basically you can either divide a to a minus 1 comma 1, or 1 comma a to a plus 1. So these are two operations that you're allowed to do. Okay, and what will be the minimum number of operations to make this array a single element? The question was very straightforward. The solution is also very straightforward. So for a moment, let's just analyze if we only have two numbers. What if the numbers are 1 comma 5? In one single operation we can make it 6. That's it, the answer is solved. What if it is 2 comma 7? What if it's 2 comma 7? Now what will happen if both the numbers are non 1? I'll convert this 2 to 1. So it will, in one step it will become 1 1 and 7, then it will become 1 and 8, then it will become 9. So it took me 3 steps. What if it were 3 comma 7? It would the answer would be 1, like what would happen, 1 comma 2 comma 7, then it would be 1 comma 1 comma 7, 1 comma 1 comma 1 comma 7, and then 1 comma 8, then 1 comma 1 comma 1 comma 8 actually, then 1 comma 9, and then 10. So this would be the flow. Okay, now, so why did I divide the 3 and why didn't I divide the 7? Because if I divide the 7, the ones will be in present in large quantity, right? Rather than the number of ones present after dividing 3, the numbers of 1 would be very large and number of operations would also increase, but we want minimum possible operations, so we will divide the minimum possible number in ones, complete ones, all the, and we will keep dividing until all the numbers are 1, and then we will keep adding to the next number. Okay, so if I have to divide 3, so how many steps would I need to make all of its numbers 1, which would be 3 minus 1? And how many additions operations would I need to perform? The number of additions operations would be 3 itself, because there will be 3 ones and every one will get reduced in one operation. So you needed three operation to what we say, decrease the number of elements, and 3 minus 1 two operations to increase the number of elements. So total number of operations required were 5. Okay. Now, so basically total number of operations were 3 plus 3 minus 1. So if your array is like this 2 comma 4 comma 8, the total number of operations would be 2 plus 2 minus 1 plus 4 minus 1. Alright. So basically it will be sum of all elements except largest plus sum of all elements minus 1 except largest. So this would be the answer for this question. That's it. Moving on to problem 3. So what does the third problem I would say? Uh, okay. So basically you are, I hope you have read the question. I'll still explain it in short. Basically you are given you have to find a permutation for given number such that let f of n represent let f of n represent all the prefix where actually all some of some of the prefix elements where element is greater than k, greater than equal to k, I guess. Okay, and g of n denotes sum of the prefix elements where element is less than equal to m, and you want to increment like maximize summation of fn minus summation of gn. So the best approach that I came up with, I haven't seen the intended solution, but the best approach that I came up with was, the answer is pretty simple. The answer will be one of the following. It will be either you go from n n minus 1, n minus 2, n minus 3 dot 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 until k, followed by 1 to k minus 1, or the answer would be n minus 1 dot dot until m and followed by 1 to m minus 1. The answer would be the one which provides better score in these two permutations. Okay, so this was my solution for problem 4. If you have any better solution, please comment it uh, in the comment section. So moving on to next problem, which was very interesting problem actually, problem D. So test of love. There are various ways to solve it. Some solved it using DFS, some solved it using DP, some like like similar thing to DP, not exactly DP. And people like new people like me solved it using brute force. I hope you have read the question. If you are on land, what you can do, you can jump out next, jump anywhere up to m steps. If you are water, you can move ahead, but you can only be on at most k waters, kws basically. And if you're at crocodile, you are dead and you cannot go any further. So basically you have to check whether you can reach the end position before all, without going more than kws, and without like going through sea. You can also like directly jump, what we say, jump skipping sea, right? So these were three possible operations. The my solution was very simple. Whatever string you are given as input, add one L before and one L after. This will represent the final bank and this will represent the initial bank, because you can initially jump M steps as well. So it can be L or start or end. So by adding L before and after, the start and end problem gets solved. Now, if you are on W and K is greater than 0, what you need to do, just subtract K once and increment I. If you are on C, you're at very bad luck, you just print no and end. Okay, if you are on land, now this is the main part, and I'm literally done the brute force. You don't have to think anything. If you are on land, so your m gets recharged. Okay, let's say initially m was something, or basically you got m moves. Now you got m moves. Moves is equal to m, so you can move m steps ahead. So while you still have moves, now if you are on water, you don't need to subtract k because you can just jump. So you skip. If you are a crocodile, you don't need to be scared because you can skip, so you skip. If you are on land, just recharge the moves because now you can again jump k steps forward, m steps forward. So recharge moves to be m. That's it. That's it. This was the only question, and this is enough to solve the question. Okay, if L, you have M moves while moves are still remaining. If you are on water, just ignore because you cannot do anything. Just skip it. If you are on crocodile, you cannot do anything. Just skip it. And if you are on land, just recharge your moves because now again you can move, jump M steps. Okay, that's it. And one more case here. If you are on water and k is less than equal to 0, you have to print no and end. So this was the only simple logic present for this question, which I came up with during the contest. Again, if you have any better logic, do comment it out. The problem E, and this is the problem I most want to discuss because F is easier than this, I believe, because you really need good thinking, good implementation to understand and implement this problem. Okay, problem is not hard, but understanding of this problem is very important, and understanding why the solution works. Problem 5. Okay, now let's say, uh, given an integer n, you, I hope you have read the question. So we need to find if a into n minus b is equal to a n a times minus, actually n a minus b times. You just need to check whether how many a and b this condition holds true. Okay, you just need to check how many a and b this condition holds true for. So this was a very easy question because a was less than equal to 10,000, n was less than equal to 100. Okay, now if you loop for every n and then for every a, if you find all possible values of b, find possible values of b, your answer will be solved. Okay, so this was the idea actually ki, since n can be less than equal to 100 and a is 10 power 4 for every possible n, then for every possible n, inside that for every possible a, just find all possible values for potential values of b. Not possible, actually potential. For every possible a, for every possible n. And now the main thing is, we want, what do we want? We want that a into n minus b should be equal to n n how many times? A minus b times. Am I right? We want this to hold true. Now, so basically, since uh, since a is less than equal to 10,000 and b is less than equal to 10,000, this n and n cannot go more than 5, right? So this difference cannot go more than 5. If both the values are less than equal to 10,000, of course their multiplication, uh, and n is 100, right? N is 100. So a into n minus b at worst case can be 10 power 6, 10 power 4 into 100 minus 1, which will be nearly equal to, like nearly equal to 10 power 6. So this value should not go greater than 6. So n would be always be less than equal to 6, because at worst case a n minus b will be actually 9999. Okay, so it should be less than equal to 5. If even if you do 6 7 for extra security, it won't cause any trouble to you. So n should be less than equal to 5. Now, how would we check? So my approach was, for every difference, like let's say our n is 2. So for difference is equal to 2. Difference means this value a into n minus b. This is our difference. Okay, and this should be in the form of n n n n n, right? So for if n is equal to 2, my potential differences are 2, 22, 2 to 2, 2 to 2 2, and 5 times 2. So these are my potential differences. Now for each potential difference, what I would like to do is, what I'd like to do is for A, actually for B from 1 to 10,000, I would find, but actually I'll do it ulta. For every possible difference and for every possible B, I find potential values of A. Why? Because you can go both ways, that's not a problem. I just did it this way. So for every possible B, now my value of A should be, so what is difference here? So my difference would be, remember, it would be 2, 22, these values, okay? So for every possible B, potential A is equal to B plus difference into, you have B plus difference. So potential A into N is equal to B plus difference. So potential A would be B plus difference upon N. So this is only possible if B plus difference modulo N is equal to 0. अगर ये divisible है तो भी तो possible होगा ना ये. So if this is possible, potential A will be B plus difference upon N. Because as you can see here, if you simplify this equation, difference plus B is equal to A into N, and difference plus B upon N is equal to A, right? So difference plus B upon N is equal to our potential A. So if this potential, if this potential A is also less than equal to 10,000, is also less than equal to 10,000, then then so I want this difference uh, to match the value of potential of, so so this difference should also match this n value, right? So basically n how many times? Potential A minus B times absolute of potential, actually potential A minus B times, right? Now how would I check that? So f- I have this difference, so this is difference string, right? So before applying it, I will convert it to difference integer. I'll convert it into integer form of itself. So I'll typecast it and I'll use difference int here, okay, for like better understanding. Difference int, and I'll typecast it outside. Okay, now this makes sense. Now for so if this satisfies, I'll also make an pair of like vector pair array outside to store these values. So if I like write the generalized form, there would be an answer pair of answer where pair will be present, okay? Now if potential is less than equal to 100 plus less than equal to 10, potential is less than equal to 1e4, and B is also less than equal to 1e4, and B into B sorry A into N minus B is also equal to difference. Now the only thing which is remaining to check is whether this N occurs uh, potential A minus B times. The only thing that is remaining to check is this. So what I'll do difference dot substring potential from 0 to potential A minus B. That's it. So if, and then I'll convert into integer again. So int or difference int 2 will be int of difference. So if difference int is, if difference int equals difference int 2, then I'll insert it in our answer. Difference int comma difference int 2, that's it. And while checking this difference, we also need to ensure that our difference in int should be less than difference dot size, because if it grows greater than this length, then of course the difference won't exist, and that basically would erase the entire string itself. So you need to take care of that. Okay, so this was the complete logic. If we want to dry run on it on some case, let's dry run on 2 only. So for 2, first we will check, so what are the potential values of 2, differences of 2? It will be 2, 22, triple 2, 4 times 2, 5 times 2. Now for every value, for every b from 1 to 10,000, what I'll do, so is 1 plus 2, which is equal to 3, divisible by 2? No, it is not divisible by 2. So I'll move on. I'll check, continuously check. Let's check for 22. Okay, let's, and b is 18. For a moment, let's assume b is 18. We'll just verify our facts. If b is 18, so, and currently the difference is 22. Let's assume that as well. We are checking for 22 and we have reached b value 18. So potential a into n would be 18 plus 22, which is equal to 40. Therefore potential a would be 40 upon n, which is 2, which is equal to 20. So potential a is now 20. So, and difference is, so so now the only thing that remaining to check is this difference equal to potential a into n minus b? If both the things are like same, this number and this different string, then I'll directly put into the answer. So 18 comma 2 fits in our answer. So yes, b plus difference was divisible. So I found the potential a. Yes, potential a is less than equal to 10,000, and difference int is less than equal to difference dot length, because difference int is 2 and difference dot length is 2 as well, less than equal to. And then I compared and it is valid, so I put it in the answer. So this was actually my complete approach for the sim. So this is its code. I'll share the link in the description. Moving on to next question, which was actually easier than E. I hope you have read this question. So if you're not, I'll tell the question in short. Problem 6. So you are given an array and an integer x. Of course, the array will be of length n and an integer x. You want to divide the, let's say the array is a2, a4, a5. You want to divide this array in segments. Segments is basically sub arrays. So a1, a2 in one sub array, a3 to a5 in one sub array, such that in no subsequence of these segments should have product exactly equal to x. So this is basically just the question. So no subsequence of this array, this subsegments should have any subsequence exactly divisible by x. For example, if I take this test case to discuss, so I can I include 2 in the first segment? Yes, because I don't have a product exactly equal to 4. Can I include 2 comma 3? Yes, because I still don't have any product exactly equal to 4. Can I include 2 3 6? Yes, because I still don't have any product exactly equal to 4. Can I include 2 here? No, because if I include this 2 here, this 2 into this 2 will be exactly equal to 4. So I cannot include this 2 here. I'll separate it out. So I'll separate the 2 here. Can I include this one? Yes, I still don't have any product exactly equal to 4. Can I include this 2 here? No, because this 2 and this 2 will be equal to 4, or this complete array will sub array will be equal to 4, so I cannot. I'll separate it out. So I needed total of 3 segments. So the answer is 3. So such we need to find the minimum number of segments. Okay. So how would we do this? How would we do this? So the basic simple approach which I followed is, we'll carry a set set containing the elements which we don't want. Let the name of the set will be don't want. I don't want these elements in my segment. Okay, initially don't want will contain rx because we don't want x anywhere. Okay, we don't want x anywhere. Now we'll start traversing. Now start traversing for element from 1 to n. So if element is not divisible, not divisible by x, then continue, because it won't matter if it is not divisible. No matter whom you multiply this element with, you will never get x, because element itself is not divisible by x. For some elements to be divisible by x, they all should be factor of x, right? ऐसा कोई नया एलिमेंट आके x से डिविजिबल नहीं हो जाएगा. हर कोई फैक्टर लगता है. सो इफ एलिमेंट इज नॉट डिविजिबल बाय x, it will, no matter what you bring, nothing multiplied by this element will ever bring you x. So we can always include it in our current segment. So initially let segment is 1, because we consider that whole array is one segment initially. We don't need to divide it anywhere. So include it, no problem, go ahead. Else means now our current element is divisible by x. Okay, if the current element is divisible by x, for for don't DLE over don't want. So for every element on this don't want, I'll traverse all the elements and I'll check whether this ELE divides anyone from don't want. If ELE modulo don't want is 0. Why am I doing this? Let me explain the logic first. Okay, I'll take this test case and let's understand what exactly is happening. What exactly my approach is. So initially don't want is 1 lakh. I don't want 1 lakh baba, and my forget about this code for a moment, and my segment is 1. Okay, so can I include this 50,000 in my segment? Yes, I can include 50,000 in my segment. But once I include 50,000 in my segment, I don't want a 2, because 50,000 into 2 will give me 1 lakh. So once I include 50,000 in my segment, I don't want 2. So I'll add a 2 in my don't want list. Can I include 25,000 in my segment? Yes, I can include the 25,000 in the same segment, but after including that, I don't want 4, because if I get any 4, 25,000 into 4 will be 1 lakh. Can I insert 12,500 in my segment? Yes, but after that I don't want any 8. Okay, so this is basically my approach. So I'll carry the don't want segment, and if I ever find any element, so I'll continue 6,200. I don't want 16, and then I don't want 32. So then the new element is 2. Oh shit, 2 is one element from the don't want segment, so I cannot continue this segment. So my number of segments will become 2, and my don't want array will again only contain 1 lakh, because everything else which we found before is deleted. Okay, now can I keep so since I have included 2, I don't want 50,000 now. 50,000 now. Since I'm including 4, I don't want 25,000 now. Similarly, the total number of segments will remain 2 at till the end. Let's take some good example. Let's take the first example itself, okay? To understand it again. Initially, my don't want will contain 4. Now I'm on the first element. Yes, I can include it in a number of segments is 1. Yes, I can include it, but after including that, I won't want 2, because 2 into 2 will be 4. Yes, I can include 3 as well, because 3 is not divisible, no problem, continue. Yes, I can include 6 as well, because 6 is not divisible by 4. Now again I got 2. Oh shit, I didn't want it 2, because 2 is present in my don't want list. So I'll increment the segment, I'll create the don't want list. Okay, it will only contain 4, because 4 is x and we don't want x. Now there is this one, and of course now we don't want 2 again, because we have inserted this 2 in the segment, and another 2 will make the product 4. Can I insert 1? Yes, because 1 is not in my don't want list, so I inserted 1. Can I insert this 2? Oh no, 2 is in my don't want list, so I'll clear the don't want list. I'll make the segment size 4, and I'll insert 4 in my don't want list, which it is x. So my final answer of number of segments will be 3. Let's take one final example to understand this, and I hope you create a don't want list and number of segments before I do. Segment is 1, don't want is empty. So 27 initially. Okay. So can I include this 3? Yes, I can include this 3, but after including the 3, I don't want 9. So 9 is in my don't want list. Oh shit, I got 9. I cannot include it here. So I'll empty the don't want list, increment the number of segments. I'll insert 27 in my don't want list and also insert 27 upon 9, which is 3 in my don't want list. Now I'm on 17. No worries, it is not divisible. 26. No worries, it is not divisible. 2. No worries, it is not divisible. 20. No worries, it is not divisible. 9. No, it is divisible, and since 9 is in my, not in my don't want list, 27 upon 9, which is 3. I'll insert 3 in my don't want list. 3. Oh, 3 is present in my don't want list. Let's clear this list. Let's increment the segment and insert 27 and 27 by 3, which is 9. So basically, our answer is 3 this time, which is same. So this was the logic. We created one font list. We initially insert x. For every element which is not divisible, we don't care, we continue. If it is divisible, for every element in the don't want list, we traverse. And if we check whether something is divisible by that element, if it is divisible, we insert don't want to insert element upon d element. Why do we do this? I will tell you. And before doing this all, if element dot find in don't want, increment segment, don't want को clear कर दो and don't want dot insert x. This, that's it. And why do I doing this? I'll tell you why this loop is important. So for example, let's say at there are 3 elements. The target is 8 and our array is 2 to 2. Okay, I is here. Initially segment is 1. Don't want is equal to 8. Can I insert this 2? And there is 3 here as well, just to make it comfortable. Yes, I can insert this 2, but I don't want 4 anymore. Okay, can I insert this 3? No matter, it is not divisible by 8. Can I insert this 2? 2 is not in my don't want list, so I can insert 2. Okay, because until here there are no elements which product up to 8. Now after inserting 2 in this list, I don't want 8 upon 2, which is 4, and I also don't want 4 upon 2, which is 2, because it will get multiplied by the 4, and then it will get the product of 8 will be also created. So 2 will be also inserted in my don't want list. So whenever I try to insert it in the segment, what I do, I traverse the don't want list, I insert 8 upon 2, and I also insert 4 upon 2. So I'll insert all the elements divided by the current element if it is divisible. So I then move on to the last element. I cannot insert in this don't want list because so I cannot insert it into the same segment because it is present in the don't want list. So I increment the segment, I clear the don't want list and set it to 8 again. So number of segments will be 2 in this case. First will be 232, the second will be 2, and this is the logic of this. I hope you understand. If you don't, please go back and watch the video again. Thank you so much for your time. Grow well, learn well, and don't leave CP. It is very important. Bye bye.